This lecture explains important properties of binary tree. Binary tree is a special type of tree. The node will be having at most 2 children. These are the important properties of binary tree. First property says that in any binary tree, maximum number of nodes on level L is 2 raised to L. So all these can be explained with the help of an example. Take this example. This binary tree has 0, 1, 2, 3. 4 levels, 0, 1, 2 and 3. We have 4 levels and the last level is 3 since the level starts from 0. The property says that maximum number of nodes on level L is 2 raised to L. This tree is not the one with the maximum number of nodes. So we'll draw one. So consider this tree with only one node. Maximum number of nodes is 1. The equation says that is 2 raised to the level 2 raised to 0, that is 1 node. So maximum number of nodes possible in level 3 is 2 raised to 3, that is 8. That is this shows maximum number of nodes in level 3, that is 2 raised to 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. Second property is minimum number of nodes possible in a binary tree of height h is h. So you need to find out. First we need to define height h of a tree. Height h of a tree is maximum number of nodes possible in a path starting from root to the leaf. You need to find out maximum number of nodes starting from root to leaf. So if you take this example, the maximum number of nodes starting from root to leaf is 1, 2, 3 and 4. So in this case, for this example, the height of this tree is 4. Or I can say that height of a tree is maximum level number plus 1. The levels are 0, 1, 2 and 3. The property says that the minimum number of nodes possible in a binary tree of height h is h. So which says that if the height of a tree is 4, then minimum number of nodes possible in that tree is 4. Obviously, this is not the one with minimum number of nodes. So if you are drawing one with minimum number of nodes, you need to draw like this. One node in the 0th level, one node in the next level, one node in the next level, one node in the next level. This is a tree with height 4 and the minimum number of nodes possible is 4. Next property is, for any non-empty binary tree, if n is the number of nodes and e is the number of edges, then n equal to e plus 1. Number of nodes equal to number of edges plus 1. So if you take 2 nodes, the line that connects these 2 nodes is called the edge. So if you have 2 nodes, the number of edges is 1. So if you take these 3 nodes, number of edges is 2. Or in general, I can say that number of nodes equal to number of edges plus 1. Or number of edges equal to number of nodes minus 1. That is the third property. And the fourth property says that height of a complete binary tree with n number of nodes is log n plus 1 to the base 2. So if you, in this case, you are considering a complete binary tree. So for example, consider this complete binary tree. So the number of nodes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You have 15 nodes. Height of this tree with n number of nodes is log n plus 1 to the base 2. You need to take the ceiling. So here it is. Height of the tree is log n plus 1, that is log 16 to the base 2. Log 16 you can write it as log 2 raised to 4. This again you can write it as 4 log 2 the base 2. Log 2 the base 2 is 1, which means that 4. Or you can see that height of this tree is 4.